Question was about the function f of x that's equal to 9 times the quantity x plus 3 plus 2 if f is less than 6, 6 times the quantity x plus 3 plus 2 if f is greater than or equal to 6. How do we graph this? Well, first thing we probably want to do is go ahead and sketch a coordinate plane. Then we want to, okay, the definition of this function is different when x is less than 6 than when x is greater than or equal to 6. Now what's that mean? Well, let's let's put 6 right here. So of course this is the x-axis, this is the y-axis. So x equals 6 divides the plane into two parts. Okay, on this side, x is less than 6. On this side, x is greater than 6, and on this line, x is equal to 6. This definition applies only to the part of the plane where x is less than 6. So we can graph this function. It's nothing but a straight line, but we only graph it up to the line x equals, where x equals 6. At that point, the graph of this straight line stops. Now, in general, the graph of a function which is defined as a straight line, if you don't have any restrictions on it, goes from negative infinity to positive infinity. It never stops. But in this case, this graph has to stop at x equals 6. So, what's this graph? Well, first of all, 9 times x plus 3 plus 2 equals 9x plus 29. And that's going to be the linear function that we graph on this side. That's the point slope form. So we would have y equal to this, from here all the way over to this point. To the right of this point, and including this point, and we'll see how that works in a minute, our function is y equals 6 times the quantity x plus 3 plus 2, which is 6x plus 18 plus 2. And that, of course, simplifies to 6x plus 20. Okay, well, this function has a slope of 9 and a y-intercept of 29. This function has a slope of 6 and a y-intercept of 20. Now, those slopes are both pretty big, and 20 and 29 are pretty big numbers compared to, say, 6. We're not going to be able to get them both on the y-axis as it's sketched, so I'm just going to fudge the scale a little bit. And I'm going to put, let's put 30 here, so that 20 would be about here, 10 would be about here. So 20 would be about here. So this would be the y-intercept of this function. But, of course, this function doesn't exist or doesn't apply on this side of the line x equals 6. So what are we going to do about that? Well, I'm still going to mark this as a point. And we have a slope of 6, so that this function is going to go up 6 for every unit it goes over, which means, for example, that if we go over 6 units to get to the line x equals 6, we're going to have to go up 36 units, which will put us up at 56. So I can make sure that's right. Yeah, that's right. Okay, so that puts us up at 56. So I can plot the point. If this is 30, then 40 is going to be here. 50. 56 is going to be up about here. Okay, so what we have here is the point 0, 20. Up here we have the point 6, 656. And our line y equals 6x plus 20 would go through these 2 points. Now I've got myself into a little bit of trouble here because this line continues to be steep and continues to go up here, and I don't really have a good place to put it. So I'm going to make a couple of changes to this graph. I'm going to change the scale yet again. Okay, I should have planned that out just a little better. So I've changed the scale of the graph. 020 is now down here. 656 is up here. And if I take a straight edge through these points, I don't want to draw a line on this side of x equals 6 because this function doesn't apply on that side. So I can sketch a straight line here, and that's going to be the graph of this function for x greater than or equal to 6. Now this point is included, so I'm going to put a big filled in dot at this point to indicate now that this line represents this function for x greater than or equal to 6. The dot indicates that the point on this line is really a point of the graph. Now the function y equals 9x plus 29 is going to have y-intercept 0.29. So I'm going to put that here. And it's going to have a slope of 9. Well, we could find the x-intercept. We just set 9x plus 29 equals 0. We find the x-intercept is at negative 3 2/9. Well, the intercept then, let's see, if this is 6, this is 3, so 1 is about here. So, well, negative 3 would be about here. Negative 1 here, negative 2, and so forth. And a little more than negative 3, we have the point then negative 3 2/9, 0. These 2 points lie on the line, and we can now graph the line. So taking a straight edge through these points, I think the line will come out something like here. This point where x equals 6 doesn't lie on the graph of the point, the graph of the line on this side, so we put a big blank circle there. Now 9 times 6 is 54, you add 29, you get 83. So this point here should be the point 683. And now this is the graph of our function. It's a split graph. It's a split definition. On this side of x equals 6, we have this line, not including the point where the line reaches the point where x equals 6. And on this side, y equals 6x plus 20, including the point 656. This line then extends from here on out to the right and up. This line is steeper than this line. We can see that pretty clearly. It's somewhat steeper. The slope is 9. The slope of this line is 6. This line is about 50% steeper than this line.